called as nitrite. So these are the class of what? These are the class of substituted product. Okay. So by using KCN as the reagent, nucleophilic reagent, which nucleophile is generated? Cyanide group is generated. So what is happening? The Br is replaced by the CN group, and we are going to get what? Cyanides or nitrites. Okay. Then the next is if we are using AgCN. Okay, important. So this we are going to see the difference. So if we are using AgCN, so here the product obtained will be a isocyanide. Okay, isocyanide means what? In cyanides, okay, the attacking agent is your carbon will get attached, okay, to the substituted product. Now here in isocyanide, here N between the nitrogen and carbon, nitrogen will get attached to the substrate group. Okay, so what is the product formed is isocyanide, okay, or isonitrites. Then if you have potassium nitrate, okay, if you have potassium nitrate, what is the product obtained? It is a nitrate, okay, ethyl nitrate. So from potassium nitrate, what will be the nucleophile generated? The nucleophile generated will be Na2 minus, okay, NO2 minus. So we are going to get what? Ethyl nitrate as your product, okay. Then if you have silver nitrate, what will be your product? It will be nitroethane. You can see nitro substituted product you will yield. So we'll get nitroalkanes. What we will yield? We will yield nitroalkanes. Okay. Then
What
if
is called as NO3, ma'am?
NO,
3. What is the name of NO3?
we we don't have NO3.
No, ma'am. I have generally asked NO3.
NO2 is there, NO is there, NO3, just a second. If I have NO3, potassium nitrate will be KNO2 only. Okay, then if I have nitrate, NO3 minus, okay, it is also a nitrate ion, NO3 minus, NO3 minus, okay, NO3, it is a nitrate ion. Okay, you can call it as nitrate ion. So for the test of nitrates, so we use that nitrate ion. NO3 minus, not NO3, it will be NO3 minus. Okay, so next, just a second. Okay, so we were discussing, so when you have ethyl bromide as your starting reactant, and if you treat it with sodium alkoxide, so this is a sodium alkoxide. Okay, this is a sodium alkoxide. This is called as sodium alkoxide. What will be the class of product obtained? This is a ethers. Okay, ROR dash linkage. So this is what, when you have O linkage, then it is called as what? It is called as the ethers. So the class of products obtained is what? It is a ethers. Then you have this. You don't have for the NaC double bond. This is not there. Okay, we'll go with the last one. So this, okay. When you have your substituted this what? So this is in the form of ester. Okay, ester is what? O, C double bond O, R, okay, and R dash. So like this. So this is your ester. So these are the different. So we have seen the different examples. Okay, we have seen different reagents from which different nucleophiles can be generated. And by using these different nucleophiles, we can do the nucleophilic substitution reactions. Okay, so these are the different nucleophiles. Now here, when we have seen in this, okay, when we are treating the alkyl halide, okay, with a sodium alkoxide, what we are obtaining? We are obtaining the ether. Okay, we are obtaining the ether, and this name reaction is called as what? Williamson ether synthesis. Okay, so this is a named reaction which we are going to study in the chapter okay, about the ether. So that time we are going to study about Williamson ether synthesis. So by using this method, we can prepare what? We can prepare ether. Okay. So by treating your alkyl halide with sodium ethoxide or sodium alkoxide, we can obtain the corresponding ether. And this same reaction is called as Williamson ether synthesis. Now there is something called as amphidentate ligands. Okay, what do you mean by amphidentate ligand? The examples are CN and NC. Okay, just now we have seen. So please remember this amphidentate. Just a second. Ambident nucleophile. Okay, ambident nucleophile. Okay, so what do you mean by amphidentate nucleophile? Okay, when a nucleophile is having two nucleophilic centers. Okay, when you have two nucleophilic centers, okay, two nucleophilic centers, but they link only through one center, but links with only one center at a time, okay, is called as amphidentate nucleophile. Okay, so this is what. So when you have two nucleophilic center, okay, so amphidentate nucleophile is what? A nucleophile which is having two nucleophilic center. Now, for suppose here you can see CN and NC. Okay, so these two CN can also link from C, and it can also link from nitrogen. So when carbon is the nucleophilic center, that time what will happen? It will form cyanides. Okay, and when nitrogen, okay, your nitrogen is the nucleophilic center, then it will form what? Isocyanides. Okay, so the class of products which is obtained will be different. Okay, so this is the definition of amphidentate nucleophile. So two nucleophilic centers, but links only with one center at a time is called as amphidentate nucleophile. One more example is nitro, NO2 minus. Okay, next is NO2 minus. So this is also a example of amphidentate ligand. Okay, so it can link from oxygen also, or it can link from nitrogen also. Okay, so nitro group is also amphidentate ligand. It can link through oxygen, and it will form what? It will form alkyl nitriles. Okay, alkyl nitrides. And if it links with nitrogen, then it will form nitroalkanes. What it will form? Nitroalkanes. So these are the different this. Okay. Now next we are going to see. I just told you. Okay, KCN and AgCN. So here, okay, haloalkanes. So these are haloalkanes, right? So haloalkanes, when they react with KCN, okay, they form what? They are forming alkyl cyanides. Okay, they are forming alkyl cyanides as the main product. So the main product obtained is your alkyl cyanide. And while when it reacts with AgCN, what it forms? It forms isocyanides. It forms what? Isocyanides as the main product. So what is the reason why the products obtained are different in both the cases? Okay, here only it is potassium cyanide, here it is AgCN, that is silver cyanide. Okay, but the product obtained are different. Why? What is the reason? Okay, when you see KCN, when you see potassium cyanide, it is ionic in nature. Okay, what do you mean by ionic in nature? Okay, it can easily form the ions. Okay, when you add this in water, it will dissociate into K plus ion and Cn minus ion. So KCN is ionic in nature, and therefore what will happen? Both the carbon and nitrogen, so they are free. They are free to link with the alkyl halide. So any one of this can link with the alkyl halide. Since the carbon-carbon bond, okay, when you're comparing the carbon-carbon bond, it is highly stronger. Okay, it is stronger in case of KCN as compared to that of the, so CC bond is stronger than your CN bond. Okay, so because of that, carbon will get attached to the alkyl group. Okay, and it will form alkyl cyanide as a product. So what is the reason? So as KCN is ionic in nature, so it will dissociate into K plus ion and Cl minus ion. So carbon and nitrogen both are free to link. So since carbon-carbon bond is stronger than the carbon-nitrogen bond, so carbon will get attached with the alkyl group and it will form alkyl cyanides as the main product. Now, when you compare with AgCN, okay, now when you compare that with AgCN, this AgCN, it is covalent in nature. Okay, it is said to be covalent in nature. What do you mean by covalent? Mutual sharing of electron takes place. Okay, that is okay. So mutual sharing of electron takes place. So that is AgCN. So AgCN is a covalent in nature, and that time what will happen? Only nitrogen is available for linking. Okay, only nitrogen will be available for linking, and hence they will form what? They will form alkyl isocyanates. They will form alkyl isocyanates as the major product. So this is the reason. Understood? So what? So like this, the question is asked. KCN, haloalkanes react with KCN to form alkyl cyanides and as a main product, and AgCN forms isocyanide. Okay, as a main product. Explain. So what you will explain? KCN is ionic in nature. Okay. So here both carbon and nitrogens are free to link with the alkyl group. However, carbon-carbon bond is stronger as compared to carbon-nitrogen bond. So carbon will get linked with the alkyl. Carbon will get linked with the alkyl group, and thus it will form what? It will form alkyl cyanides. And AgCN, since it is covalent in nature, only nitrogen is available for linking, and hence it will form what? Isocyanides, alkyl isocyanides. Okay, as a major product. So like this, you have to explain it. Is it clear? Yes.
Yes, ma'am.
Okay, so just now what we have discussed is these things, okay? The note. So just you can read this, then I'll change the slide. So whatever I have explained you now, so just it is in the written form. Okay. Okay. So next we are going to start with the mechanism of nucleophilic substitution reaction. So this nucleophilic substitution reactions of alkyl halides, okay, they proceed with two different mechanisms. So we have two different mechanisms through which this okay. So nucleophilic substitution reactions, okay, they are of the alkyl halides. They can proceed via two mechanism. The first is SN1. Okay, SN1 is, it stands for substitution unimolecular, okay, substitution nucleophilic unimolecular. And the second type of nucleophilic substitution takes place is substitution nucleophilic bimolecular. Okay, so first we are going to start with SN1. That is, it is also abbreviated as SN1 mechanism. Okay, now this SN1 mechanism, okay, so here the rate of the reaction. So when we are discussing about the SN1 mechanism, so let me, okay, so this is our SN1 type of mechanism. So SN1, it is a unimolecular nucleophilic reaction. So SN1 reaction, it proceeds via two step. It proceeds via okay. So it will proceed via two step. So the mechanism, it involves two step. So step one is a slow step. So so first I'll write the reaction. Okay. So we are going to take here tertiary butyl. Okay, let me take the example bromide. Okay, plus we are going to react with the NaOH. Okay, what will be our product? Okay, so this is the reaction. So general reaction, we have to write this first. So this is what? Tertiary
Tertiary butyl bromide.
Yes. Butyl alcohol. Okay. Okay. Now here, so this is the reaction. So it proceeds with two steps. It proceeds with two steps. So step one is a slow step. Okay. Step one is a slow step. So we'll explain that first. So this involves the formation of carbocation. It involves what? Formation of carbocation. Now, what do you mean by carbocation? Carbocation means what? When you have a positive charge. Now, the same I'm going to write. So CH3, C, CH3, C, CH3, Br. Okay. Now, in the presence of, so this is a slow step, in the presence of NaOH. What will happen? As this carbon bromide bond, as you know, CBr bond is what? It is a what? It is an alkyl bond, right? So what will happen? As bromine is highly electronegative, what will happen? There will be the electrons will tend to pull towards itself. As a result, there will be partial negative charge and partial positive charge, and the cleavage will takes place. Okay, so the polarized bond, that is CBr bond, it will undergo slow cleavage. So the breaking of this bond takes place, and as a result, what will form? CH3C, CH3, CH3, and plus. Okay, so this carbon will get a positive charge. So this is what? This is a tertiary carbocation. So whenever the carbon is getting a positive charge, they are called as carbocation. And this carbon is tertiary because it is linked to three other carbons. So it is called as tertiary carbon. So this is a first step. So first step is a slow step which yields the formation of carbocation. So what will happen in the first step? The first step, the polarized CBr bond, it will undergo slow cleavage. Okay, it will undergo slow cleavage of the slow cleavage to produce a carbocation, and what is formed? Plus Br minus. Okay, bromide ion is formed. Okay, so carbocation and a bromide ion, that is Br minus, is formed. So this is the first step. Understood? Is the first step clear?
Yes, ma'am.
Okay. So now we are going to see the second step. Okay, let me clear this. I hope you have written the general reaction. Okay, so let me clear this now. Okay, now here. Okay, so second step is a step two. Step two. Okay, so step two, it what happens? It is a fast step. So this proceeds via a fast step. So what will happen? The carbocation which is formed in the first step. Okay, the carbocation which is formed in the first step. So here the attack of nucleophile takes place very fast. So what will happen? The attack of nucleophile takes place at a fast speed. Okay, so this is a fast step. So what is the product obtained? And you obtained a tertiary butyl alcohol. What you obtain? Tertiary butyl alcohol. So this is the product. So nucleophile attack. So what you have to write? Fast step, and this is a nucleophilic attack of nucleophilic attack on carbocation. Understood? So nucleophilic attack on carbocation. So this is the second step. It is a fast step where what will happen? The carbocation which is formed in the first step. Okay, we are going to attack it with the nucleophile. Okay, and to form the substituted product which is a alcohol. So first step. Okay, this first step, it is a, so this is not reversible step. Okay, it will go forward step. First step is a slowest step and it is a reversible step. Okay, and what will happen? The rate determining, this is called as the rate determining step. It is called as the rate determining step. Okay, now here the rate of the reaction. So when we are calculating the rate of reaction, it depends only on the concentration of substrate. Okay, that is the concentration of alkyl halide. It depends upon the concentration of alkyl halides. Why? Because as it involves the ionization, you can see Okay, what is happening when we are taking the alkyl halide? Ionization takes place. Okay, slowly due to the presence of this polar bond. Okay, due to the presence of this polar bond, slowly the ionization takes place. Right. So what is happening? The energy which is required to break this CBr bond, it comes through the solvation of this halide ion. So we are using the organic solvent. So what we have used here, NaOH. So NaOH can be used, water can be used, okay, or some other organic solvents can be used, which will help in the cleavage of this CBr bond. Okay. Now, when we are discussing about the stability, when we are discussing about the stability of the carbocation, okay, the tertiary alcohols are more stable, then your secondary, and then your primary for SN1 mechanism. So when we are discussing about SN1 mechanism, tertiary alcohols are more stable as compared to that of secondary and then the primary. Is it clear? Yes, this much is clear.
Yes, ma'am.
Okay. So this is the reactivity. So the order of stability of carbocation. So when you are discussing about the carbocation, tertiary carbocation is more stable than secondary and then the primary. Okay. Now, so the stability is very important. So the order of reactivity of alkyl halide is very important. So tertiary alkyl halide is more stable than secondary, then primary, and then your methyl carbocation. So SN1 mechanism, it proceeds by a two-step. So first step is the formation of carbocation step, which is a slow step. Okay, and it forms a tertiary carbocation. And the second step is a carbocation and forms the substituted product, that is a alcohol. Okay. So as we have discussed, okay, what are so the features of the SN1 reaction. So as the rate of the reaction, it depends only on the concentration of the substrate. Okay, that is rate is given as rate is equals to K into Rx. Okay, rate is given as K into Rx. So this is the rate of the reaction. So the rate of the first order, that is and this is a first order reaction. Okay, it follows the first order kinetics. So SN1 reaction, the rate of the reaction, it depends upon the concentration of the substrate, and it follows what? It follows first order kinetics. Then we have discussed the reactivity of alkyl halides. Tertiary is more stable than secondary, then primary, and then the methyl carbocation. Then which are the polar solvents? So polar solvent, usually low concentration of nucleophiles and weaks the nucleophile, favors the SN1 mechanism. So because of the presence of polar solvents, what will happen? The concentration of the nucleophile will be low. As a result, it will favor the SN1 mechanism. Okay. And what will happen in SN1 mechanism? Partial racemization takes place. What do you mean by racemization? Yes, do you know what do you mean by racemization? Do you know what is retention? So first we'll understand what is retention and what is inversion. Then you will come to know what is the inversion. Now, when we were discussing about the reaction, okay, that is CH3, CCH3, CH3, okay, Br plus OH. Okay, what is happening? You will get CCH3, CH3, CH3 and OH. Now, when you compare the reactant and when you compare the product, okay, when you complete the reactant and product, what is the change? The only change in the nucleophile. Okay, here the leaving group will leave and here the nucleophile will get attached. Okay. Now, what the product which is formed, okay, it is said to be retention. Okay, why it is said to be retention? Because you can see that the relative arrangement, okay, you can see the relative arrangement of these bonds, okay, are what? They are remaining the same. The arrangement of the bonds in the reactant as in the product are same. Okay, after the reaction and before the reaction, it is same. So it is said to be what? Retention of configuration. It is said to be retention of configuration. So when in their starting reactant and in their product, if the bonds relative arrangement is the same, okay, then it is called as what? Retention of configuration. Now, what do you mean by inversion? What do you mean by inversion? Okay, so that we are going to study in the SN2 mechanism. Suppose, okay, suppose I have, okay, let me take like this. So CH3 Br plus OH giving you, okay, OH OH, CH3. So what you can see, the relative arrangement of the bonds, okay, or I'll make it more clearer. Okay, CH3Br, 3H plus OH minus, giving you CH, and OH. Okay, now you can see the relative arrangement of the bonds, okay, in the starting reactant and in the product form is different, right? Here the Br is in front, here the OH is in backside. So this is called as inversion of configuration. Okay, it is said to be inversion of configuration. Now, what do you mean by racemization? Just now we have studied, no, that this will undergo racemization. Now, what do you mean by racemization? When you have, okay, so when the starting reactant, which we have seen in SN1 mechanism, okay, so starting in SN1, what we have seen, okay, it is called as retention and this is inversion. So when you have 50% that, okay, that is retention of configuration, and when you have 50% inversion of configuration, then what you will obtain, so what is present, so 50-50 mixture of both this A and B products will be formed, and this process is called as what? Racemization. So when you have 50% inversion and when you have 50% retention, then it is called as racemic mixture. Okay. So in SN1 mechanism, partial racemization occurs. Okay. There will be formation of what? Partial racemization is possible in SN1 mechanism. So but what we write, this is stereochemical aspect. Stereochemical means what? When we are studying the molecules in 3D form. Okay, when we are studying the arrangement of molecules in the 3D form, so that time we are going to study about stereochemical aspect. So stereochemical aspect after finishing. Okay, now here you can see. So front or backside. So when the attack will takes place from backside. Okay, now this is the carbocation, right? This is a carbocation with carbon and positive charge and R1, R2, and R3. Right. Now, if the attack of the nucleophile takes place from behind, okay, from backside, then what will obtain? Then what will obtain is inversion of configuration is obtained. Right. Inversion of configuration is obtained. If the attack takes place from front, if the attack takes place from front, then what is obtained? Retention of configuration is obtained. So retention. Okay. So what is obtained? So what you can see, that whenever SN1 mechanism is there, when you are comparing the stereochemical aspect, it forms racemic mixture. Okay, so two possibilities are there. If the attack takes place from behind, then inversion. And if the attack takes place from front, then it is retention. So this is a racemic mixture. Understood? Yes? Okay. So next we are going to see the SN2 mechanism. What is SN2 mechanism? Substitution nucleophilic bimolecular. Bimolecular. Now in SN1, okay, it was unimolecular. Unimolecular means what? The rate was depending only on the concentration of the substrate. Okay, it was depending only on the concentration of the substrate. Then it is called as SN1 mechanism. Here in SN2 mechanism, the rate of the reaction depends on the concentration of the substrate, okay, as well as the nucleophile, also the nucleophile. So it is said to be SN2 mechanism, and this follows second order kinetics. Okay, this follows second order kinetics. So now we'll study about substitution, that is nucleophilic bimolecular reaction. So here in SN1 reaction, it proceeds via two step in SN1. In SN2, this reaction proceeds via one step. So it is a one-step mechanism. So here the reaction undergoes via one step, and it is second order reaction. The rate of the reaction depends on the concentration of the substrate as well as the nucleophile. And during the SN2 reaction, what is possible? Inversion of configuration is possible, and this inversion of configuration, it is called as Walden inversion. Okay, very important. Mark this important. So in SN2 mechanism, what type of inversion is seen? It is called as Walden inversion. It is called as what? Walden inversion. Understood? Okay, so let us see the so let us see the mechanism. Okay, so here when you are comparing the SN2 mechanism, okay, now when you're comparing the SN2 mechanism, so let me take, so H, Br, okay, so this is a primary, what is this? It is a methyl bromide. It is a methyl bromide. Now, what we are going to do? We are going to attack it with the nucleophile. So the nucleophile will attack from the behind. Okay, the nucleophile will attack from the behind of the carbon. Now, what will form? What will happen? So this carbon, okay. So here you can see these hydrogen, okay, are present. Then here the OH bond is forming, and here the simultaneously the CBr bond will be broken. So what will happen in Walden inversion? Yes, what you can see that simultaneously the making of bond. So this is a making of new bond. Okay, we are making the new bond, and here what is happening? Breaking of new bond is possible. So breaking of old bond. Okay, so here this bond is broken and this bond is we are making. So carbon, so carbon has a tetravalency, right? So here you can see it is having what? It is having pentavalency. Penta means what? It is having 5 hands. Okay, it is not possible. So carbon is unstable. Carbon is unstable. So it is undergoing what? It is undergoing a transition state. What it is called as? It is undergoing a transition state. And what is happening? The product formed will be a inverted product. So this is a inverted product. Is it clear? So whenever we are discussing about SN2 mechanism, so SN2 mechanism, it proceeds via one-step mechanism. Okay. And in SN2 mechanism, what is happening? The attack of the nucleophile. The attack of the nucleophile, it takes place from the behind. Okay, it takes place from behind. And what will happen when it is forming? So the breaking of the bond. So as you know, so this is a CBr bond, and it is what? It is a polar bond. So what will happen? So partial negative, partial positive charge will bond, and okay, as the attack is taken from backside, okay, so it will undergo a transition state. In transition state, you can see that. So this bond is been you are making the new bond, and the breaking of the old bond takes place simultaneously, as it is pentavalent in nature. Okay, so it is unstable. So this is a unstable, and this is called as a, it is undergoing a transition state, and you will obtain the methyl alcohol as a product. Okay, methyl alcohol as a product. So the nucleophile. So let me explain you with the correct. I'll give you the sentence. Okay, so the nucleophile OH minus. Okay, the nucleophile OH minus, it attacks the positively charged carbon. Okay, from the rear side. Rear side means from back side. Okay, back side. So that what is happening? So that the leaving group, okay, to that the leaving group, and it will undergo a transition state. It will undergo transition state when you're forming of new COH bond, you are making a new CH bond, and you are breaking, okay, and partially CCO. This transition state, it is an unstable state. Why? Because carbon is in its pentavalency. So because carbon is in its pentavalency, okay, it is unstable. So what will happen? So it will form the substituted product easily. So the alcohol formed has a inverted configuration. Okay, as you can see, the starting product and the final product, it is inverted. The product obtained is inverted, and this is called as what? It is called as Walden inversion. It is called as Walden inversion. Now, when we are discussing about the stability, okay, now here, okay, now here primary alkyl halides are more stable, then secondary, and then your tertiary. So why primary alkyl halides are more stable here? Okay, now when you are attacking the nucleophile, okay, when you are attacking the nucleophile, you can see in primary there are only hydrogens. Okay, now there are hydrogens. Now suppose if I attack the nucleophile on a tertiary carbon, you might have that doubt, right? So that we will take a tertiary on the tertiary carbon, why the attack is not possible. Okay. Now let me see. So let me write it more. So these are the CH3 groups of the tertiary carbon. Okay. Sorry, H, H and H. And what is happening? Here the attack of the nucleophile is taking place. Okay, Br. Now what is happening? What you can see in primary alcohol and secondary alcohol, in tertiary alcohol. Yes, why we are using primary alcohol and why we are not using tertiary alcohol? These are the bulky groups. Okay, and the attack is not possible. It is hindered. Hindered means there is a steric hindrance. Steric hindrance means what? Yes, there is rush there, right? You can see there is more rush here. So here, so whenever you are doing SN2 mechanism, primary alkyl halides are more stable, then secondary, then tertiary. Okay, so we are going to take what? We are going to take primary alkyl halides, or methyl carbocation is also more stable. So this is the reactivity series. So very important reactivity series. So in SN1 mechanism, what is more stable? Tertiary carbocation is more stable, then secondary, then primary, and then methyl carbocation. In SN2, it is reverse. Primary carbocation is more stable than secondary, and then the tertiary. Is it clear? Yes. Are these two mechanisms clear?
Yes, ma'am.
Okay. So if you have any doubts, you can ask now, okay? Because later it will be again difficult. So you can ask your doubts now itself. Okay, others have also understood. So what is SN1 and compulsory question? Okay, please mark this as important. SN1 and SN2, both the mechanisms are important. So first you have to write the general reaction and then you have to explain the mechanism with the steps. Okay, so SN1 as well as SN2 mechanism, both the name reactions are very important. Okay, fine. Okay, I have a question for you all. Okay, so please tell me. Okay, so here I have two reactions. I have two reactions. Okay. I have two reactions. The first one, I have this molecule CH2Cl and Cl, and I have one more. Okay. So in this following pairs, so these are two following pairs are there. Okay. So of the halogen compounds, which will undergo SN2 mechanism faster, in the following pairs. Okay, tell me. So for SN2 mechanism, what is the criteria? Primary alkyl halides are more stable than secondary and then tertiary. So this is the condition you have to see, apply and put here. Okay, first one. No. Uh, First one. Okay, others. So what is the this year hybridization of first one, methyl group? Okay, so Cl group is attached to the carbon. Okay, here. So what is the carbon halide group is attached to CH2. So this is what? It is a primary carbon, right? It is a primary carbon. Now here carbon Cl. Okay, that is Cl is attached to two more carbons. So what is the hybridization? It is a secondary carbon. Okay. Now here, see this. So your iodo, it is attached directly to the one carbon. It is attached only to one carbon. So this is also primary. Now here, Cl is directly attached to one carbon. So this is also primary. So, as compared to this one, so this will undergo primary, primary alkyl halide. So this is more reactive for second SN2 mechanism. So this first one is more reactive, okay, for SN2 mechanism. Then when you're comparing second one, okay, both are primary, both are primary. But what is, you have to now see the nature of the living group. Nature of the living group. So we have seen nature of living group. So what is the nature of living group? When we are seeing the nature of living group, okay, better the living group, what is the order was? I minus is better living group, then Br minus, then Cl minus, and then F minus. So between Cl and Ido, which is better living group? First one. Okay, so we are going to take the first one. So here I minus is better living group than Cl minus. So this will undergo SN2 mechanism faster. Is it clear? Yes. Okay.
Yes,
So
ma'am.
next. Okay, so next we are going to study the stereochemical aspect. So this stereochemical aspect, we shall take it in the next class. Okay, any doubts? Okay, others? Any doubts up to yours? So next we are going to see the stereochemical aspect. Now, what do you mean by stereochemical aspects? Okay, that some terms are there, important terms, so that we are going to discuss. After that, we have some more chemical reactions. Okay, then we are going to see the chemical reactions of haloalkanes, then haloarenes. Okay, and then polyhalogen compounds. Okay, so any doubts up to your?
No, ma'am.
Okay. Pavitra, you had a doubt, right? So, in which group you are there? You're from which college? You had a doubt
Malleshwaram
regarding
Medium
solution.
Course College.
Okay, okay, fine. So, okay. So, what you can do, I'll drop you my number here. Okay. You can just, whatever doubt you have, you can ask me there. Okay, fine. So, regarding the, what is that? Solution chapter, you had a doubt, right? So that you can ask me there.
Yes, ma'am.
Okay, fine. So others, no doubts regarding whatever has been told till now. Fine. So we shall end the session here. Yes. So we'll meet in the next class. Yes, on Monday. Okay. Thank you.
Thank you, ma'am.